All right, Algebra 1, let's talk about absolute value equations and inequalities. First of all, what is the absolute value again? What is the absolute value of a number? Isn't that its distance from 0 on a number line? Does this sound familiar? On the number line. So how would we solve this? How would we solve this guy? Well, we can do we can approach this a couple of different ways. Actually, I don't want to do this guy. I want to do a different problem, sorry. This is what we're going to do. All right, how are we going to solve that problem? It starts out just like solving any other equation. We have to isolate our variable. So we have to subtract 2 from both sides, and now I have an absolute value of x equals 7. Well, when we think about it, there are 2 numbers on the number line that are 7 spaces away from 0, right? We have down here on the number line positive 7, and we have negative 7. So this could equal either positive 7 or negative 7, right? Because we know from our vast experience in math that absolute value of 7 equals 7, and the absolute value of negative 7 equals 7. So what we need to do is set 2 different equations, right? One is going to be equal to the positive, and one is going to be equal to the negative. And when we do that, we drop the absolute value bars. So now we have x equals 7, or over here, x, whoops, not there, x equals negative 7. And we already know that's true because we've identified on the number line the 2 numbers that are 7 spaces from 0. So overall, these are the steps that you want to follow when you're solving an absolute value equation. You want to isolate the absolute value on one side of the equation. And notice that this is a little bit different than how we've defined isolating a variable, right? When we isolate a variable, it has to have a coefficient of positive 1. When we isolate an absolute value, the whole absolute value has to have a coefficient of positive 1, right? So if we have x equals 2, this absolute value is isolated. If we have x plus 2, absolute value equals 2, this is considered an isolated absolute value. If we had 3 times x plus 2, absolute value, this is not, right? We would have to divide both sides by 3 to isolate the absolute value, okay? So the first thing we have to do is isolate the absolute value. Whatever is in between those bars, that has to be all by itself on one side of the equation. Then we solve for both the negative and positive possibilities. And we're going to set up 2 equations, just like what we did in the last example. So let's do a couple more examples. Let's solve this guy. Well, we don't have an isolated absolute value, so first things first, let's add positive 5 to both sides, and I get absolute value of n equals 3. All right, I'm going to drop my absolute value bars and set n equal to 3 over here, and n equal to negative 3 over here. And we know that's true, right? Let's find out. Let's check. Let's say absolute value of negative 3 minus 5 equals negative 2. We have to evaluate this before we can add anything. So what is the absolute value of negative 3? Well, that's 3. Now we add left to right, and we get negative 2 equals negative 2. What about with positive 3? Absolute value of 3 minus 5 equals negative 2. Again, we have to evaluate. The absolute value is an operation, okay? These bars signify an operation, so we have to perform that operation before we can add and subtract. Adding and subtracting is always last. So what is the absolute value of 3? Well, that's 3 minus 5 equals negative 2, and we already know that's true, right? Negative 2 equals negative 2. Boom. Q-E-D. Right? Okay, let's try one more. Now in this case we have the variable isn't all by itself within the absolute value signs, but the process is the same. This is an isolated, this is an isolated absolute value operation. So we're going to write two equations from this step. One is going to be r minus 8 equals 5. We drop the absolute value signs. And this one is going to be r minus 8 equals negative 5. Because the absolute value is just a distance from 0 on the number line. And this could evaluate to either 5 or negative 5. Okay, so let's just solve. R equals 13. We're just adding 8 to both sides, right? Over here, we're going to add 8 to both sides again. But here we get r equals 3. Well, let's check. And let's do it in a different color. Let's start with absolute value of 13 minus 8 equals 5. Let's perform this absolute value operation, and we get absolute value of 5. And yes, indeed, absolute value of 5 is, in fact, 5. What about over here? Absolute value of 3 minus 8. And notice that I'm substituting these values, right, back into the original equation. We don't substitute into our derived equations. We substitute them back into the original equation. So here I get absolute value of negative 5, and yeah, we happen to know, because we're smart cookies, that absolute value of negative 5 is 5. All right, I want you guys to try this one on your own in your notes. Okay, let's see how smart we really are. How are we going to solve this one? We have a few operations we have to perform, right? What are we going to do first? We could divide through by 3. Or should we move that 12? Let's get rid of the 12. Let's say 3 absolute value of 2z plus 9 equals negative 12. And then we're going to divide both sides by 3, right? And we get 2z, absolute value of 2z equals negative 4. Notice, though, that if we were to actually divide through by 3, we would have to divide each term, right? If we were to do this first, we'd get to the same place, because we would end up with absolute value of 2z plus 9 plus 4 still equal to 0, and then we would have to subtract 4 from both sides, and we would end up with absolute value of 2z plus 9 equals negative 4, and that's exactly what we have here, right? Okay, so back to this. We've isolated our absolute value operation now. We have to, well, wait a minute. Is there any situation Is there any set of circumstances that you can think of where we could put a value in for z here and get a negative evaluation over here? Because think about it, if we put any number in for z, let's say 2 times 1 plus 9, that's going to be a positive number. Absolute value of, let's say, let's put in negative 20 for z. 2 times negative 20 plus 9, negative 40 plus 9, we still get negative 31, but the absolute value of that is a positive number. There is no set of circumstances in which we can isolate an absolute value and have that equal a negative number. So this is a big fat no solution. Yeah, there we go again. We see this everywhere, don't we? No solution. In inequalities, absolute value equations, all over the place. Some problems just can't be solved. Okay. Now we're going to, let's take a look at these guys, and we're going to graph these because something interesting happens when we do this. We get some pretty cool, what we call compound inequalities. So notice that we're doing inequalities now, but all the standard rules of solving absolute value equations, and from what we know about how to solve inequalities, we're combining those now to do absolute value inequalities. So, let's say n new, we got hang on, I'm just having trouble with this stylus. It's all over the place. Okay, so let's say n minus 1 is less than 2. But it could also be greater than negative 2, right? Because whatever this evaluates at, we could have less than 2 or greater than negative 2, right? Because if this absolute value, oh, why isn't it writing, evaluates at 2, it's just like setting our equations equal to both the positive and the negative. But now why did I flip the sign here? Why would I flip that sign? Because what did I have to do to get a negative number over here? I had to divide through by negative 1, right? So we end up with a compound inequality, and this is called an AND inequality. Well, what about this guy? If we do our two inequalities, whoops, where did I get 1? Let's erase that. How are we going to graph this? With the shaky graph. Again, we have negative 2, and we have 2, but in this case, n minus 1 is greater than 2, and n minus 1 is less than negative 2. So these graphs don't overlap. This is called an OR inequality. So either of these cases can be true and satisfy this inequality, but they both can't be true at the same time. Whereas up here with our and inequality, they can both be true at the same time. Okay, we'll get a lot more practice with this in class, but I just wanted to plant the seed so you guys can start thinking